we will continue with the carboxylic acids. In this we have already done IUPAC naming and preparation of carboxylic acids. Now we will start with properties. In this, first is physical properties and then the chemical properties, and then in the today's lecture we will do physical properties and the main acidic character of carboxylic acids. So first is physical properties. In the physical properties, the main properties are solubility, then boiling point, and then the melting point. First is solubility. As we already know, carboxylic acids can form hydrogen bonding with water, so they are soluble in water. That is, this is a carboxylic acid molecule. This can form hydrogen bonding like this with water molecules. So these are soluble in water due to the formation of hydrogen bonding. But as the size of alkyl group increases, the polarity of OH group decreases. Therefore, the hydrogen bonding becomes weak and the solubility decreases. So lower members are soluble in water, but when the alkyl group increases, then the solubility decreases. So next is boiling point. In the boiling point, we see the hydrogen bonding between the same molecules, that is between the carboxylic acid molecules. So they have higher boiling points because the hydrogen bonding between the molecules is very strong, and due to this hydrogen bonding, they exist as dimers and they have higher boiling points. So next question comes, why carboxylic acids have stronger boiling points than the alcohols? We have already done that alcohols also have higher boiling point because they also have hydrogen bonding. But in carboxylic acids, the hydrogen bonding is still stronger, so carboxylic acids have higher boiling points than the alcohols. It has two reasons mainly. First is OH bond is more strongly polarized due to the presence of adjacent electron withdrawing carbonyl group. Due to the presence of this carbonyl group, this OH group gets strongly polarized. And the second reason is molecules of carboxylic acids are held together by two hydrogen bonds. One is this hydrogen bond and second is this hydrogen bond. Due to this, carboxylic acids have higher boiling points or stronger boiling points than the alcohols. This is important points. So next is melting point. The melting point increases regularly with increase of molecular. So next comes the acidic nature of carboxylic acids. The carboxylic acids are acidic in nature. This we already know, but how it can be explained? The carboxylic acids gives carboxylate ion plus H positive ion. Now the carboxylic acids are resonance stabilized and the carboxylate ion is also resonance stabilized. So let's see their resonance structures. So carboxylic acid is this RC double bond OH, and the resonance structures, if this electron moves to this pi electron and the electrons present on oxygen 2 pair, these electron moves towards this, there will be a double bond, single bond O negative, and the electrons of oxygen are moved to this. Therefore one lone pair is left and it will have now positive charge. It becomes electron deficient, so it has positive charge. So there are two resonance structures of carboxylic acid. Similarly, carboxylate ion has also two structures. This is the carboxylate ion. If these pi electrons move to this, the electrons of this oxygen moves towards the in between. So this is double bond and O negative. This will have two lone pairs left, and then this there are 6 electrons. So these two resonance structures of carboxylate ion are equivalent, but these are not equivalent. This we will explain further. That is, these structures of carboxylic acid, these two structures are not equivalent, because in this structure is having no charge, there is no charge separation, but in this there is present positive charge and negative charge, both charges are present, so they require energy to keep them separate. So this has a higher energy, and so it is still some extent less stable. But in carboxylate ion, this structure has one charge negative, and here also it has one charge only, so it requires no charge separation, and moreover these two structures are equivalent, that is one double bond O, one single bond O negative, double bond O, single bond O negative, these two structures are equivalent, so these are more stable. But in this structure is double bond O, OH, single bond O negative, double bond OH positive, so these are different structures, not equivalent structures, so these are less stable and these structures are more stable. So the carboxylate ion, or we can say carboxylic acid, has a tendency to change into carboxylate ion to a more stable ion by releasing H positive, which explains its acidic character. That is, the carboxylic acid resonance structures are not so stable as the resonance structures of carboxylate ion. So carboxylic acid has a tendency to change into this more stable carboxylate ion by releasing H positive, which shows its acidic character. So carboxylic acids are acidic in nature due to the more resonance stabilization of the carboxylate ion by releasing H positive ion. And for explanation you can see this. So next is, out of phenol and carboxylic acid, which is more acidic? Now carboxylic acids are more acidic because in this the negative charge is dispersed, or we can say we can explain its acidic character on the basis of the hybrid structures of the ions found from this. Phenol gives phenate ion thus, and carboxylic acid gives carboxylate ion thus. In the phenate ion only one oxygen is present, but in carboxylate ion two oxygens are present. So in this the electronegative atom is 1, and in this two electronegative atoms are present. So here the charge delocalization is more than in this. So there are two electronegative atoms to delocalize the negative charge, but here one electronegative atom is only present to delocalize the charge. So this is more acidic and this is less acidic. So carboxylic acid has a more tendency to change into carboxylate ion as compared to phenol to the phenate ion. So carboxylic acids are more acidic out of phenol and phenate ion. And this the structures of phenate ion and carboxylate ion are to be described, not these structures. So next is effect of substituents on acidic strength of acids. Now acidic strength of carboxylic acids depends upon the groups attached to it. The groups may be electron releasing groups or donating groups, say, and second is electron withdrawing groups. The electron releasing groups increases the electron density on the ring. When they increases the electron density on the ring, the negative charge gets intensified, because already negative charge is present in the ring, so it gets intensified, hence the acidity of carboxylic acid decreases. In general, greater the groups with positive inductive effect are present, that is alkyl groups are present, then there will be a lesser acidic strength of carboxylic acid, and the positive effect of alkyl group increases in the order. This is more electron releasing group than this, than this, than this. So the electron releasing groups decreases the acidic strength. On the other hand, electron withdrawing groups increases the acidic strength of the carboxylic acid, or say carboxylate ion, by delocalizing the negative charge, hence increases the acidic strength of acids. And the order is This is stronger than this, then chloro, then bromo, then iodo, then phenyl group. So we can easily explain on these facts. Formic acid is stronger acid than the acetic acid. This is formic acid, HC double bond O OH, CH3C double bond O OH. This is acetic acid. Now, and this is a group with electron releasing effect. It is group with positive intact effect. So it increases the electron density here. In that case, in turn, this electron density is increased and the oxygen will not attract the electrons of hydrogen, and this release will be difficult. But in this case, there is no electron releasing or withdrawing group is present, so it will be released easily as compared to acetic acid. So it is a stronger acid than the acetic acid. And similarly, out of chloroacetic acid and acetic acid, which is stronger, this can be easily explained. In chloroacetic acid, chlorine is at present, Cl, CH2COH, CH3COH. That is, in acetic acid, one hydrogen is replaced, then we get chloroacetic acid. Now, this is an electron releasing group. This is also electron releasing group, but in this one hydrogen is electron withdrawing group. So here electron withdrawing group is present, in this electron releasing group is present. So this electron withdrawing group has negative inductive effect. It will displace the electron towards itself, and the release of H positive will be easy as compared to in this, in which this electron releasing group, it increases the electron density here, it increases here, and so release of H positive becomes difficult. So the chloroacetic acid is more acidic than acetic acid. Similarly, benzoic acid and out of acetic acid, which is stronger acid, can be easily explained. Now, benzoic acid is stronger acid than acetic acid, because in acetic acid, in benzoic acid, to the carbon to which COH group is attached, that is, this carbon is sp2 hybridized, and in this, the carbon to which COH group is attached, that is, this carbon is sp3 hybridized. So now this carbon has less S character, that is 25%, and in this it has more S character. It has more S character. So in general, acidity increases as the electron negativity of carbon atom directly attached to COH group increases. So in this, more S character is present, so it is more electronegative. Or we can say the hybridization of carbon atom directly attached to COH group changes from this to this. That is, here S character is only 25%, 33%, and here it is 50-50%. So in this, the sp2 carbon is present, in this carbon is sp3. So it is sp S character is more, this carbon has more S character, it is more electronegative. And benzoic acid is more acidic, because in benzoic acid COH group is attached to sp2 carbon atom of phenyl group, while in the acetic acid COH group is attached to sp3 carbon of methyl group. So we can say that formic acid in general is more acidic than benzoic acid than the acetic acid. If we have another examples, that is, out of these, which will be a stronger acid, here the group is Cl, electron withdrawing group is present, here the NO2 group is present, and now we know that NO2 group is stronger electron withdrawing group. So this will be a stronger acid. So it is stronger acid than this. And now out of these, phenol and acetic acid, which is more acidic, this is more acidic, because in this 2 oxygen atoms are present to delocalize the charge, but here only 1 oxygen is present to delocalize the charge. Now carboxylic acid does not give calcic reactions of carbonyl group. Why? We know that in carbonyl, this group is present in aldehydes and ketones, but in carboxylic acid, here OH is also present, due to which here 2 lone pairs are present on the oxygen, and these electron pairs can move to this and this to this. So there is a resonance. There is a resonance due to which now carbonyl group is not free. It is involved in resonance. Therefore, it do not give the catalytic reactions of carbonyl group, and it is not a free group. So this is all about the physical properties and the acidic strength of carboxylic acids. In the next lecture, we will continue with the chemical properties of carboxylic acids. So thank you.